Okay, with this video, let's take a look at the Quick Graph online graphing tool. It's a very simple, straightforward graphing tool that's online. And when you do your labs and everything, you collect your data. The first thing you have to decide to do with your data when you want to put it on the graph is which one is the independent variable that you changed and which one is the dependent variable that changed because of that. So let's say you're doing a lab where you had something moving along a certain distance that you're measuring the time it took and the distance that it moved. And so what you want to be able to do then is say, well, if I maybe measured time every second, then I could say that would be my independent variable or what I changed. Right? So say I did the lab and I measured how far it went every second along the way. All right, so I can put in 1, 2, 3, 4, and 5. We'll just do 5 seconds here for this example. And so we did that. You notice nothing shows up here in the graph because we only have one coordinate. We only have the x right now. But you notice on the x-axis, it's put the label in there for you, time in seconds. And it's also put it up in the title of the graph, which is always going to be the dependent variable versus the independent variable. So if your time was your independent, that's what you changed. The distance the object traveled as that happened would be the dependent variable. All right, and again, it fills it in the title and on the axis here for you. So now we can put in some sample distances. Let's say 4 meters, 9, say 12, maybe 17, and say 20. Okay, so now I've got, and you notice as I started putting in those numbers there, the y coordinates, now it can graph it, it can plot those points here because we have the x and the y coordinate that we're looking at here. All right, another nice feature that this has is, let's say you made a mistake here. Maybe it wasn't time being the independent variable. Maybe you had the distances set. You did it every 4 meters, 8 meters, 12 meters, and so on. If that's the case, and you put your data in here and you had them in the wrong place, you just click switch right over here, and it switches the axes for you. Right, so if you do happen to have them in the wrong place, you don't have to go back and type everything in over again. You just have to click switch right there. So that's how you put in the data, and that's the basics of it. There's a few other things you want to do, kind of clean it up a little bit, maybe do, put a best fit line on there, things of that nature. So one of the first things you want to look at the graph here is we always want our graphs to kind of be zoomed in, kind of take up as much of the actual graphing area as we possibly can. So what we'll do is you come down here to set axes, right? And so we'll click on that, and we want to manually scale. We want to set it. So let's see, our maximum y-axis went up to 20. So I'm just going to change 40 here to 20. And the x went out to 5, so I'm going to put that right there. And then that just changes, it scales it a little bit. The last point's right out here in this top corner. Sometimes it's a little bit, it's not as easy to do it as that. You might put up to 25 and have a little extra space there. But if you can get it all the way to the end there, that's the best thing you can do with that. You can close that. So that's how you can do that. You can change it back to automatically scale if you want to. The next thing you want to be able to do with this is to look at the mathematical relationship by drawing a best fit line on here. So the curve fit, or a best fit curve or line, because there is linear, that's the line, but there are other options. There's squared, which is a quadratic. There's cubed, there's inverse, exponential, different various forms and so forth you could put in here. Most of what we're going to see is linear and squared, which is the quadratic, and then the inverse. Those are the three main ones that we'll see. This one looks pretty much like a straight line. You can put that, you can see it draws a nice line in there to kind of average out all those points there to show the relationship. But you could look and say, well, I'm not sure. So you click the square, well, that definitely doesn't fit. All right, I can go over here and click on the inverse, and nothing. Right, so linear is definitely what I want here. And so it puts it right up there on that for me. So now I got a nice little graph here that has the best fit line. And you'll notice down here in the data set box, it has the equation of a line, y equals mx plus b, where b is our y-intercept. Okay, and what's important here really is the m, that is the slope of the line. So it tells me the slope is 4, and then we can put the units with it. In this case, which would be meters per second, right? So it's giving me a speed of 4 meters per second. Then the correlation, that just means how close is it to a linear relationship, and we get a 0.99 there. 1 is a perfect linear relationship, so that's pretty close. Obviously the data is real, so it's got a few numbers that are off a little bit from where the straight line would go as you look at it. All right, now a few extra little nice features on here to kind of add to this is down here where it says data set, we could change that. We could say, I'm going to say this was a marble, right, that was rolling along in the table maybe. I'll say it was a marble. So, okay, so that's the data set for a marble. And I'm saying that because I can change and put different data sets in here. So I can come down over here, it says change data sets, and I can just click on this, and it goes to data set 2, 3, 4, 5, and give them different colors. And so now we're back to data set 1, which we call the marble. So I can go over here, say we did more with this experiment, and we also did a little toy car, right? Did a similar relationship with it. And let's say we had the same settings, so we did every second. We did 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. And let's say this one, we'll just make this a little bit quick and easy to let you see it. And you see it's being graphed down here on there. And so now we've got the car, but there's no equation here in this because we haven't done a curve fit yet. So you can go in here for this one and do the curve fit while you're in this data set, and it still looks linear. And so now we have our equation for this line, the slope of 1 on this one, which makes sense. It was just the same numbers on each one, so rise over run is just 1. Perfect correlation in that case. But you can see on here on the actual graph the both lines showing the data of both of the objects here. It shows them in different colors for you so you can differentiate between the two of them. Now, once you have your graph made, you want to be able to actually add this to your lab report or submit it as a separate file with your work or print it out or something like that. And so one of the easiest thing to do with that is come down here to this little arrow under the graph, and that expands the graph out so it's a little bit bigger, and it also shows the equations of both of the lines that go along with the data in this case. And then you can just right click on that picture anywhere, that graph anywhere, and you'll save the image as, right, and it'll download it to your computer, and then from there you can name it and either paste it into a document or just simply use it separately. You can print it out of the document. You could copy the image. You could just actually copy it and then paste it into the document that way, however you want to do that. But you want to get the image from the actual graph here, and then you can go back to close it down again and see all the various pieces there. Don't use the save graph feature that's on here. I don't think it works quite like it's supposed to, and usually when you click on the save graph and go to copy this link, it actually resets all the extra stuff you put on there. It just leaves the data in there. So you have to redo the curve fits or the scaling and all that kind of stuff. So it doesn't seem to be really useful. So just do a picture of it. You can always do a screenshot or something like that, but just right clicking on that is probably the easiest way to do that and get the information that you need there. Now there's one more feature on here. All right, so every said I've got one more feature that I want to show you here, and that is an import data feature. So click on that, and basically what it lets you do is just copy some data from a spreadsheet that you might have or any kind of data collection tool that we might use in class, or some simulations and things like that. You can paste all that data right in here. And I want to show you that with one of the simulations that's actually used from the same website, and this was a simulation of a disk rolling down an incline. And so I've already run it, and you can see it graphs it so you can kind of see what's going on. But the very last section down here is actually all the data that came from it, as if we were to actually collect that data in the class. It shows you the time in this column, the position in the second column, and then the velocity is here, which is what's graphed up above. What you can do then is come down here and select all of that, and then you can copy it, and then you can go back over to the quick graphing program or import that we just did, right? And we're going to paste that, and it's just plain text. And so now it's all pasted in there, but it doesn't show up because we don't know what's supposed to be on the X or the Y. We still have to determine what's the independent, what's the dependent variable. And generally the first column is usually the independent variable. That's just the format that we use. So I'm going to put time there. All right, so it fills in all the time in the column over here, so you don't have to type all those in. And then let's say I want to do the position. So I'll click on position for the y-axis, and it shows the position versus time graph there. There's a quadratic relationship in this case because the disk was accelerating as it rolled down the ramp. I could change it then. I had velocity in here as well, and it graphs that for me. And so I can then work with it, do the same thing I was doing with some of the other examples where you can name the data sets, do linear fits, different fits, and so forth like that. It allows you to import the data there, so if you have some collected or you get a sample set of data or whatever you can use, you don't have to actually type all that data in, but you can simply import it right there.